Okay, so this lesson is about proving trigonometric identities. And so you might ask yourself, what's an identity? Well, an identity, sorry about I apologize about my handwriting in advance, because it might not be too well, because I have to use a computer to write it. But anyways, an identity is an equation, equation, that's terrible, I'm sorry. An equation, um, that is always true. Nope, don't want that to pop up. Always true. Yes, that's how I'm writing that. Because it can't be proven wrong. So, in trigonometry, it's really important to know and remember these identities because they help you solve problems with actual numbers in them. Um, Something to note about proving identities is that proving is a little bit different than solving the actual equation, because it's proving is a little bit different. In uh, this lesson's about proving identities, meaning we are not focusing on actual numbers uh, and solving equations. We're proving, for example, that, um, for example, something like cosecant theta. So like cosecant theta equals 1 over sine theta, which is an identity, so that's just as simple as it gets. That's one identity, which I'll show you in a minute. So, I'm sorry about the mic. Um, some easier identities that are easier to remember are identities that are ratio and reciprocal identities. Um, like these ones, cosecant theta equals 1 over sine theta is a reciprocal, and then the two other reciprocal identities are secant theta equals 1 over cosine theta. Why did that happen? I don't know. I'll fix that. 1 over cosine theta. Bam. And then the other one would be cotangent, C-O-T, theta equals 1 over tangent tan theta. Now, these are reciprocal identities, but something that makes the third one, this one, cotangent theta, something that makes this one easier to prove is what is known as a ratio identity, which is instead of writing this, you write this. Cotangent theta, that's a terrible theta, sorry, equals cosine theta over sine theta. It seems kind of counterproductive because it looks like there's more to deal with, but in reality, it could potentially change everything into just cosine and sine values, which makes the whole process of proving the identities true it makes it a lot easier. So, and this is also vice versa, so you could also write tangent theta equals sine over cosine theta. But that is how you do the reciprocal and ratio identities, and so there's that, and there's tons of identities, which I'll show at the end because I don't want to get to all of them. It'll be too long of a video. Anyways, alright, so let's get to a problem example. So, one question, here's an example. Prove that cotangent theta over cosecant theta equals cosine theta. Bam. Okay. Well, the first step would be to change everything to sine and cosines, like I've said before. So this would mean you take cotangent and make that cosine theta over sine theta, and you don't make it 1 over tangent because that's not sine and cosine. And you put that, I would put that in parentheses just to show that that's one thing, and you put that over 1 over sine theta, because those are two different, those are the reciprocal and ratio identities, and you make that equals cosine theta again. So, next step would be to copy.flip is how I was told, but it's all, you can also call it like flip and multiply, or however you feel about that. You can choose whatever to say whatever you want about it. So I used to get stuck on copy.flip, so I'm really doing this for purpose of me getting better at it, but I'm still gonna write it down because it helps by showing your work. Anyway, so to copy.flip, you would multiply. Oops, sorry, I kind of forgot about the parentheses for all the OCD people out there. So to copy.flip, basically, you go back up here. You would, let's get rid of this, whoopsie. Okay, you get rid of the cosine, and you would, or the cosine. I'm just getting rid of that for the purpose of this. Basically, you take the bottom piece of the fraction, so the entire denominator, you bring it to this side, and you flip it. You do the reciprocal. So instead of saying 1 over sine, it would be sine over 1, or sine theta over 1, which would just be sine, but it's helpful to show the fractions. So now that this is basically gone, you are able to cancel out the signs because there's a numerator and a denominator. Multiplying those together would just give you 1. So now you're left with cosine theta over 1, or just cosine. So that proves it, because cosine over 1 would just be cosine. So cosine theta equals cosine theta. So that's how you solve that problem. That's an easier problem, but now let's get into a little bit harder of a problem. It's not really the fact that it's harder, it's just the fact that it takes more steps. So I'm gonna change pages here because this is gonna take another page. The next one would be a problem like prove that cotangent theta plus tangent theta that's a theta, don't worry, equals secant theta times, I'm going to try to write this in here, times cosecant theta. Okay, that's theta. Okay, so the first step, like in the previous problem, sorry, I'm fixing my problems, would be to change everything into sines and cosines. So that would make it, put this in parentheses because it makes it easier to understand what's grouped with what. Cotangent theta, if you remember from earlier, is using the ratio ratio identity. That would be cosine, that would equal cosine theta over sine theta. And that's plus, it's a plus sign. Okay. Okay. Sorry about that. My cursor went out of whack for some reason. Anyway, and then that would be plus, okay, I'm leaving that there, I'm not getting rid of that. Plus sine theta, because tangent is also a ratio identity, theta over cosine. I'm sorry about this mess, but I'm trying my hardest here. That would equal, oh, I hope I can fit this in. 1 over cosine theta times 1 over sine theta, because secant is 1 over cosine and cosecant is 1 over sine. You change that to sines and cosines to make it easier on yourself, because this helps us do the next step, which is that the step 2 would be to get a common denominator, and this is what can add more steps to your problem, but it ends up helping you solve the problem in the end. So to get a common denominator, you would multiply everything, and we're just talking about the left side, this side up here. We want to get a common denominator because this side basically already has a common denominator if you multiply these two, but we don't have to do that because I'll explain later when we actually finish solving or proving. Anyway, let's just stick to the left side. We got to get a common denominator for these. So what we do is we multiply this side by cosine and this side by sine. So that would look like this. It would look like this would be the numerator, cosine, and I'm just gonna simplify it as I go. It would be sine cosine times cosine, making this cosine squared theta, and the bottom would be sine theta times cosine theta. parentheses plus. Then on this side, you would basically do the opposite. You would multiply the bottom by and top by sine, making this sine times sine, or sine squared, theta, over sine theta times cosine theta. Parentheses, and equals that. Sorry about the arrow, that's terrible. Anyway, next would be just simplifying. So now that you have, I'm going to go to the next page, a common denominator, and you simplify, you can add the two, you can basically combine like terms, but you don't really do that because there's no like terms. So that would end up with sine squared theta plus cosine squared theta over sine theta times cosine theta. And a lot of people right here at this step might think that you can cross a sine. I'm gonna undo that. A lot of people think you might be able to cross sine and the two signs out because it's on top and bottom, but since this is here, the plus sign, or you could have a minus sign, it doesn't matter. Since they're not being multiplied or divided on top, you cannot get rid of sine, and same with cosine, so that is not allowed. So now, this is gonna write weird, so anyways, that's a dot. After you've simplified, you will now have on the top, this is another identity called the Pythagorean identity. Pythagorean identity. Yeah. Okay, so and the Pythagorean identity is that sine squared theta plus cosine squared theta equals 1. So this identity can be, you basically use substitution, and instead of using this, you use 1 and replace it with that. So that would make it more simple, because now it's 1 over sine theta times cosine theta. A lot of the times, just a side note, a lot of the times it won't be theta on the side, but I just like to use theta because it can represent any number or any value. Some people use x or any other variable, but I like to use theta. So now your whole problem right now is 1 over sine theta times cosine theta equals 1 over cosine theta times, and I'm gonna use the eraser and just get rid of this part right here. Over 1 times sine theta. Yeah, I know it's kind of messy, but bear with me. So now, basically, what you can do now is you can, with this side, you can turn this back into two separate values of 1 over sine theta times 1 over cosine theta and that equals 1 over sine, and order doesn't matter because it's multiplication, so I'm just writing it so it's like parallel or symmetrical or whatever you want to call it. 1 over sine theta times 1 over cosine theta, and you're done, because this side is the exact same thing as this side, so that's good. And that's how you prove that. So now I've shown you these problems. So now, since I haven't explained every identity, what I'm going to do now is I'm just going to show you this page. Maybe you can take notes or do whatever you'd like with this page. But these are just more identities that I haven't gone through that help you solve or prove equations. And so, yeah. I guess that's the end of the video. Bye-bye.